Good evening, everyone. Welcome to Excelsior's information session tonight. I'm Dr. Richard Cole. I'll be your host, and we're going to talk about AI, data centers, and the nuclear energy field and how all of those are coming together over the next few years. I've been teaching with Excelsior since 2017, full-time staff and faculty in the nuclear engineering technology program since April of 2024. I'm an alumnus of Excelsior. I graduated when it was the Regis External Degree Program in 1983. And I have a master's and doctorate in adult education since then. Okay, we're also going to be joined by some from admissions. If you'd like to introduce yourself.
Hello, everyone. Good evening. My name is Bethina. I am an admissions counselor here at Excelsior. I work with different students when it comes to like the general population of students, as well as military and partnership students here at Excelsior. I've been working in admissions for almost 3 years now, and I recently completed my master's degree here in Excelsior in human resources with an emphasis in AI, as well as diversity, equity, and inclusion. So with that being said, if you do have any questions about the program or about Excelsior at the end, you could definitely feel free to ask in the chat or send us a follow-up email as well.
I'm going to go ahead and start sharing my screen. So as you should have noticed, we are recording this session for anyone that wants to come in later. I'll go ahead and go through the presentation, and then we'll open up for questions that you may have about what we talk about and about Excelsior in general. So we're going to talk about AI-driven energy demand and nuclear power. So it's hard to even think about anything anymore, and you hear about artificial intelligence all the time. And we're using it, or we're going to use it in the future. And in fact, you'll see that throughout this presentation, the graphics that I use, like on this page, were created with artificial intelligence, and a lot of my research was done using artificial intelligence and putting it together. And I find that I'm using it more and more every day. So how does that tie in AI, data centers, growing electricity demand? So AI is causing a rapid increase in demand throughout the world. It's becoming more and more infrastructure every day to support that. We're looking at hyperscale for AI campuses where they're building these data centers, and they take a lot of power, just like your computer takes a lot of power at home. Think about that on a scale of buildings full of supercomputers running all the time and answering questions from all over the world at the same time. So you're seeing these data centers heavily equivalent to power demands of mid-sized cities. So that's using a lot of energy resources. So that's taking grid planning and energy challenges, that load growth. How is that growing and straining the grid? How is that coming together? So we're going to need how do we put that together and get the power that's going to supply this rapid demand for more and more data? And how do we use that data? So U.S. data center consumption is expected to go up by a factor of probably 4 in the next 10 years. Just by 2030, probably where it's expected to use about 12% of all U.S. power will be used by data centers. So that's where you see the graph on the right, where it's going up all the time for the current near term, and then on up into 2025 and past to 2030, and then on into 2050. So worldwide data centers are using about 945 terawatt hours. So that's the equivalent of thousands of homes. If you look at one right now, the state of Virginia is the leading user of data centers. About 17% of the power in the state of Virginia right now is being consumed in data centers. Almost, and that's growing all of the time. And they're the largest for the states in the country. It'll probably be over 50% in the next 5 years. So you look at that, where is all that power going to come from? Worldwide, we're seeing increases probably as much as 165% just by 2030. So how does nuclear align with that? Data centers, one of the things they really need is they need to have reliable power. Right now, the most reliable form of power generation that we have in the United States is our nuclear. Nuclear currently provides about 20% of the power on the grid. Nuclear has a 90% capacity factor. That means nuclear is operating 90% of the time that it's planned and intended. So, yes, there can be things that can happen to where you can lose something in a plant. They may have to come down in power for some reason. Maintenance has to be done, but it's very unusual. Nuclear power plants, the ideal nuclear power plant starts up, operates for 18 months to 2 years, shuts down to refuel. That's the ideal. That would be 100% planned capacity factor. If you look at that compared to wind, is about capacity factor is about 30%. Solar is somewhere around 20 because they just can't operate all the time. The wind's not always blowing and it's not light out all the time. So that makes nuclear one of our best for scalable nuclear power. Others in renewables are growing. Nuclear is also a carbon-free power. So it's very good then for the environment and very reliable. I've been in the nuclear industry for about 50 years. I've seen it increasing in reliability throughout that time. I see that continuing on in the future. So what we see then is tech industry partnerships. About 2 years ago, I went to an American Nuclear Society annual conference. At that conference, we had people from new nuclear and nuclear saying we need to build more nuclear. One of the things we need for the small modular reactors, things you're talking about there that are coming up in the future, is they're saying we need investors to do that. At the same time, we had people there talking about their data centers, basically saying, we'll use all the power that you can sell us. We'll buy your power because we need your good, reliable power. And I'm thinking, why don't we talk to each other? So I went to another conference just 6 months later, and you started hearing these tech partnerships coming up. So now you've got Google, Meta, Facebook, Microsoft. They're all making long-term agreements to support nuclear power plant restarts. In the early 2000s, we were actually shutting down plants because we just didn't need the electricity. So plants that weren't economical to keep operating, we actually shut some of those plants down. Started using more and started using it. Gas became the most economical power at that time. Now you see they're actually starting those up. 3 Mile Island is restarting its Crane Energy Center. Duane Arnold in Iowa is a potential restart with Google. Meta is also going with power. So you're seeing that, and you're seeing that confidence that it's there. We're making these investments. The government is supporting this reinvestment in nuclear to help growth in nuclear. So all these things, we're seeing a confluence of things coming on, a lot of it driven by AI and the data centers. So we're seeing that corporate backing that's bringing some of that money in that we were talking about. Just recently, when the president was talking about this, one of the things looking at, because of what's potential for the grid, is saying if we're going to make this investment in all these data centers and AI, you're going to pay as you go. So basically, you need to help build that power to support your data centers, and that's going on. We're seeing that happening, and we're seeing that growth coming on and supporting things going on. One of the things that's really going to change that, I think, is that fits in with that idea is the small modular reactors and advanced nuclear designs. A small modular reactor is 20 to 300 megawatts, about a third the size of a typical full-scale nuclear power plant now. So that's an ideal size in some cases to go directly and build it directly alongside a large data center and supply that power. Then you don't have to build all this gigantic grid infrastructure, the power lines, the substations. Build the power plant right next to the power. It's there. In some cases, we've got closed down power plants of coal power plants. The substation is still there. The switching gear, a lot of the power lines. Potential for taking and putting a small modular reactor in that area or microreactor could go right there along with build a data center next to it. So we're seeing that starting to be put together. I think Wyoming is one of the first places where we may see something like that with one of our new small modular reactors. Microreactors are even smaller. So for a smaller data center or other small load, looking at small modular reactors will go in places like possibly in Alaska, where it's hard to get power. You could have a very reliable nuclear power plant there, smaller, just the size that you need for the infrastructure for a small city. And these small modular reactors will have different designs, much more safe designs, intrinsically safe, basically where something goes down, it shuts down and it keeps itself cool. It doesn't have the issues like happened if you look back at Fukushima. It's just completely different and new designs with this safety in mind to where basically they shut themselves down and cool itself down and become safe. But they still operate for several years. And then basically you could take it in these small modular or microreactors, you basically truck in a new one. You take out the reactor, you truck in a new one. Now, for some of the people that have been in the military, the military and submarines, that's essentially small modular reactors that we've been operating for over 50 years, completely event-free from a nuclear standpoint. They're making them to where they're refueling those about every 25 to 30 years, the life of the plant, because of the way the engineering is done. So we're seeing a lot of these things coming together. So what is it going to take to do that? Well, that's where now you see comes together is we're seeing nuclear energy careers and AI and data center, what's going on in the careers there. So if you look at what's going on and the people that are in demand in these places, it's a lot of the same people. It's the same STEM related to science, technology, engineering skills that go into the STEM. They're all together and use the same skills. So I foresee, like where we use some of these small modular reactors, you would have a group of people, because in an AI and a data center, you've got the people that do the IT, the cybersecurity, the taking care of the computer side of it. Well, to run all that, you've got to have people that take care of air conditioning, cooling air, water plants that go around that go in for the cooling, the power systems, emergency power systems, battery. These are all things that come out. So people that get nuclear energy careers, like in our nuclear engineering technology or our electrical and mechanical engineering technology programs, they're going to be in demand in nuclear, in the AI and data centers, basically the same types of skills. If you look at the people that are in a nuclear career, at a nuclear you think about nuclear engineers. Well, it ends up that only about 20% of the people at a nuclear power plant actually have engineering degrees. Most of the people that are working there are engineers, technicians, maintenance people, people to support the supply, security guards. That's what 80% of the workforce is. But a STEM background is something that's really going to be important, and we're going to need that. So what are we looking at for the growth? For these skilled technicians, the specialists, radiation protection supervisors, managers to go on, AI and data center, all these things come together. So nuclear and an AI data center takes very multidisciplinary skills. We're looking at from nuclear, we're looking at probably right now we have about 68,000 people working directly at power plants. There's 93 power plants currently around the country. And then about another 40,000 people in the supply chain in direct support. So we're looking at about 100,000. By 2050, we're looking at that's going to be more like 350,000, because looking at the scale, we need to have electricity, no matter what form of electricity and how we generate it. It's going to take people to operate that. So we're looking at about 350 to 400,000 new, very good paying jobs that are going to be coming up in the next 15 years. Just the time for the careers for hopefully some of you that are watching this evening. Things to come together. Need for carbon-free energy. So we've been doing a lot of things to go carbon-free. You know, we're looking at plug-in cars, EVs, things going on there that we want to get more carbon-free. Well, that's still going to take power. You got to get electricity to charge the car from somewhere. You know, so like here, you can go to the Wawa gas station and pull up there with they've got the Tesla charging stations there. You know, it's not real convenient to go and you know, go to the gas station for a few hours to charge your car. You know, nuclear enables us to be able to get more of that carbon-free power to support that. Getting into these partnerships, we'll be able to get it out there faster and get some of these plants that were very well-running plants. Palisades in Michigan was a great running plant. It just became a non-economically supported. Same thing, I worked at Duane Arnold in Iowa, a good running plant. It came out that my father-in-law helped build that plant in the early 70s. I learned that after I got to work there. So seeing them coming, you know, I'd love to see that plant come back online. It was a good running plant for a long time. Google's willing to put in money to help do that. So these are all things that are coming together where we need the electricity. We're going to need more and more. Excelsior, so this is going into now. Excelsior, who are we? We're an accredited, not-for-profit distance learning institution. We've been around since 1971, providing educational opportunity. Like I described, I got my bachelor's degree in 1983 while I was on active duty in the military. So we provide educational opportunity for people that are working on a full-time. About 70% of our students are currently on active duty or veterans. We have partnerships with utilities to where people can, and in the military, can use tuition assistance. You can get discounts if you're working for one of these utilities, some other partners that we have to help pay for that. And right now, almost all of our classes are asynchronous online learning, which means we meet you where you need us to go to school. Most of our classes are 8 weeks long, 3-hour classes. You go to it, it's online. You take your tests, you meet, you discuss, you talk to your other students online, emails. We use everything that we can and as strong a technology basis as we can. For the nuclear engineering technology program, we've got a pressurized water reactor similar to the power plants we've got now that our students have a chance to practice with. Military students have a chance to see what a commercial student is like. I had a student recently that was a manager of a nightclub, but he wanted to get into a career like this. So he was getting his degree in nuclear engineering technology. You can be anywhere in the country or international and take our classes. So an overview of our degree programs. To start off, we have an associate's in applied sciences and technical studies, looking at it for the STEM careers, the AI, data plants, other high-tech industries, manufacturing. That's a very good degree to help make you more competitive for an entry-level position. And a lot of times they could also be partners. We're working on potential partnerships with utilities to where it could tie right into possibly an apprenticeship and getting your associate's degree at the same time you're doing an apprenticeships. We have 3 bachelor's levels degree right now, a Bachelor of Science in Electrical Engineering Technology, Bachelor of Science in Nuclear Engineering Technology, and our newest is our Bachelor of Sciences in Mechanical Engineering Technology. Our technology degrees are engineering technology, so we emphasize getting you ready for hands-on. So this is really helping people to get ready to get into these STEM jobs, the technicians, the radiation protection, electrical, interior communications, cybersecurity ties into it. We have a big need for cybersecurity at our nuclear power plants, and then that goes with the data centers. So you'll see that. So we're helping you get you ready to do that. In our nuclear engineering technology in particular, since it's an ABET accredited engineering degree, technology degree, it makes you eligible as a graduate to apply for directly go into a senior reactor operator, where you'll be supervising the reactor operators and the other people at a nuclear power plant. Some benefits of attending Excelsior: the application is free. We maximize transfer credit. We look at what you've done already and give as much possible credit as we can. So military schools, anything you've done, other colleges, we'll put that all together, working with our advisors to help you get as much transfer credit into the courses as you can. You know, some people dropped out of school. You know, I brought in 2 other different colleges when I first went with my degree with Excelsior and brought it in, and also some online testing. We normally have flexible 8-week courses. We start courses 6 times a year. So we're in a trimesters. So all through the year, you can start courses. Convenience to start with those 6 times. Asynchronous. We're accredited, so our degrees are accredited and taken other places. You can take this degree, and my bachelor's went on, and I went and got my master's and doctorate at another 4-year institution where I was going on to do that. The programs I'm talking about for our engineering programs are accredited. ABET accredited really makes them desirable to employers. And we have our Yellow Ribbon program for veterans for discounted rates through some partnerships. So there's a lot of opportunities and very flexible where we're trying to serve an adult population. Our average student is about 39 years old, I think, right now. So most of them are adults that are working and raising families, and our instructors, a lot of them have done that. So we work with our students to do as much as we can to work with our students and help you graduate. So if you've got knowledge, if you've completed any of these things that I talked about, exams, prior learning, certifications, and training, if you're already working at a nuclear power plant and you've gone through a license program, we give credit for those license programs that you can get into to get advanced credit and going into the classes. We try and do as much as we can for our students to get you through and make sure that you get the credit for your life experience. Okay. Our associate in applied sciences specializes in electrical technologies and nuclear technologies, power plant technologies, gets you ready to work in power plants. But we're seeing a lot of people from our programs are also already going to work in the data centers because they have the skills that we need, especially some of our military that have already been working in electrical, mechanical fields, air conditioning, refrigeration that they use in a data center. All those things are power plants and data centers. Very good, easy transitions. Electrical technology. So that we have concentrations in electronics and power systems. So you can analyze, troubleshoot electrical circuits, control systems. We have applied system to do that, to where you can practice online. We're also starting up at a hybrid program. This is going on in St. Petersburg, Florida, where you'll be able to work on your degree in electrical engineering technology and go to classes supporting adult learners again. Classes will generally either nights or weekends. That should be starting up this year. Our facility is getting online. We've actually got a couple of open houses coming up in later in March, April timeframe that you can go to if you're interested in something like that, where you'd like to get more of the, be in the room with the class and hands-on and working with the systems. Also ABET accredited. Nuclear engineering technology, I've talked about that already a lot. We've got a general nuclear leadership and nuclear cybersecurity for concentrations in nuclear engineering technology. Mechanical engineering technology, this curriculum will have concentrations in robotics, nuclear engineering support, but people more want to focus on the mechanical systems, and renewable, where we've got students that are actually working out in renewables in wind farms and solar and helping to support those areas right now. But they want to get their bachelor's degree to make them more competitive, because now they want to go on from the technician. Now they want to be supervisors and leaders and managers. So we've got programs where you could do that and make you more competitive. ABET accredited programs makes you desirable. Associate science, applied science and technical program gives you entry-level skills. So electrical and mechanical, our programs are focused on getting working adults, career changers, people that want to get into good paying STEM fields and move on. We have very strong industry alignment. We have industry advisory committees to help for each of our programs that help us do that. That we take their advice on what needs to be in content and helping with that and looking at our programs on an ongoing basis. And that also helps us establish some of our partnerships with industry. So now we're really ready to open up for questions. So I'll take a look at the chat first. So if you have a question, feel free. So I'm going to stop sharing my screen now.
So we have terms that upcome every 8 weeks. So for the January start date, it's going to be the first week in January, that first Monday of the new year. And then typically there's going to be a term that starts the first week in March. I could share the academic calendar in the chat as well if you'd like, for whomever asked.
We have advisors available all the time that you can talk to, that you can go to. So if you go to excelsior.edu, you can get all the information, contact information, where to contact for advising, costs, for tuition assistance for the people that are on active duty military. On tuition assistance, the cost is about half of the standard tuition price. We've really, always catered to, in particular, to the military, I'd have to say. I have some bias from that standpoint because I spent 24 years in the Navy myself. Looking to see if, okay, they'll open it. No one in the Q&A. Well, I want to thank you for joining us tonight. I hope that I'll be seeing some of you in our classes coming up, starting off in that next set of classes that starts. And quarterly, I do a webinar where I have somebody, an executive from the industry, come in as part of our American Nuclear Society student chapter. So I had senior executives from 2 different utilities over the last 6 months and basically told me everybody's hiring. We need people. We have a workforce that's aging, and we're also looking to grow. So opportunity is there. Having your degree can assist you in that and make you more marketable when you do that. So I encourage you personally, and this is what's most important to me. If you have an opportunity to go to school, get there. I'll admit to bias. Excelsior is really one of the schools is one of the best for people that are out there on a working basis to go to school on your schedule. But that's all I have for this evening. I want to thank you for being here. I'll go ahead and I'm going to stop my recorder and go off now. Thank you. Good night.